Okay, folks, we've got a lot of ground to cover this week, so it's very important first and foremost that you read this material before you watch this video notes. Um, Once you read the material, go ahead and get started back with the video notes. Grab your textbook because you're going to need this through these notes. So this week we're going to be talking about programming modules, subprograms, and functions. So we're going to review variables and how they're stored really quickly, and we're going to talk about some data flow diagrams, and then talk about how values are passed from the main module to our subprograms. So just a quick review: a variable or a variable name is only a label for a specific memory location that's given a specific data type. Um, Now, it's also important to note that each memory address can have multiple names or labels, and we'll see how that happens here in a little bit. Um, the scope of the variable in our text is either global or local. So um, it differs from one programming language to the other, but a global variable is declared in main and is accessible by all of the subprograms beneath it. So let's take a look at example 7.10 on page 370. Okay, so we are declaring a variable in main that's called myNumber, and we declare that as the data type integer, and then we set that number to 7654, and then watch very carefully what happens here. So the processing calls the any sub program and goes immediately down here, and within this program it declares another variable by the name of my number and saves that as an integer. So let's take a look at how these variables are behaving real quick. So let's presume for a moment that all of these blocks are specific memory locations. So when you declare a variable, this variable name is is attached to this memory location or some memory location, and that memory location is identified with the data type string. So again, this is simply a label for this memory location. So so when that variable is used later on in the program, the processor knows to go to that memory location and get its contents. Now remember that the variable name has nothing at all to do with the contents of that memory location. So, and we'll see how this other stuff works here in just a moment. But let's take a look at this code. So so it goes to this subprogram, and this subprogram again declares another variable named my number as an integer. So effectively what's happening is that you have two memory locations of the same data type with that has the same label, but those are two totally different variables, because this variable declared in main is recognized in main, and then this variable declared in the subprogram is recognized in the subprogram and only in the subprogram. So let's continue to see what happens here. So there's a second variable declared within the subprogram called your variable, and it's also identified as an integer data type. So the variable my number is set to the value of 2, and again that's an integer value, and the value for the variable your number is set to my number, which is 2 times 3. So the contents of your number is 6. So then the final line of this subprogram says write your number, and that's going to be 6. So, and then at the end of the subprogram, it returns automatically to this location and executes the next line and says write my number. So watch very closely what has happened here. So again, these are two different variables. This variable in main and this variable in the subprogram any sub are two totally different variables. So the value contained in my number in main is still 7654. So when it writes my number, it still contains 7654. So it's very, very important to understand and try to wrap your brain around how those variables work and how they. Sorry about that. It's very important to understand how those variables work and how they function in memory. Take a look, if you would, at figure 7.1 on page 355. So these are this is a data flow diagram, which is effectively the hierarchy charts that we've already been using up to this point. But notice that this shows the variables that are passed from one subprogram to another, and it shows what direction those variables are moving. So pay very particular attention to that, and when we create our hierarchy charts from this point forward, we're going to be showing the data flow amongst those modules, or the subprograms rather, in that those hierarchy charts. Okay, so from this point forward, all variables will be passed from main to the subprograms below. And that's rather than what we've been doing up to this point, is declaring those variables in main. Now we're still declaring the variables in main, but we have to pass those variables either by reference or by value, and we'll discuss how that works out. And also from this point, our subprogram headers will be preceded by subprograms. So now up to this point, we've had modules, a main module, and then the modules beneath that. So now we're talking about a main program and then the subprograms beneath it. So when we call a subprogram from main and pass variables, it's going to be very important to understand how those variables behave. So the variables that are within the call statement that are enclosed in those parentheses are called arguments, and then the variables in the header of the subprogram within those parentheses are called parameters. So if you take a look at what I have in this slide, if you call the subprogram output results and send that the variables original price, discount rate, and sell price, when it lands in that subprogram called output results, these variables are still coming into that subprogram. Now watch very closely what happens with this, because you'll notice that the variable names have changed. So rather than having original price, discount rate, and sell price, we now have old price, rate, and new price. So, but these are still variables containing the same values that have been passed from the main program. Now, we'll in a few minutes we'll get into the difference between pass by value and pass by reference. Now, I want to mention that that in the text it talks about the variable names changing when it's called from main and lands in the subprograms. And it's done that way for a reason, because those subprograms, as I mentioned in some past video notes, those subprograms are typically very, very large, and each subprogram is assigned to a team of coders, and they are given specific details for what is coming into that subprogram and what is what is desired to come out. So the only information they're given is the data types and the number of values that are coming into that program. There's no information about the incoming variable names. So when they write their subprogram, they give it whatever variable names that they want, and then when it's called from that main program, those variables are pushed down to that subprogram, and it functions just as well. Now, for this class, there are many of you guys that have not written a single line of code up until you start taking this class. So, if it's easier for you to keep the same variable names from the main program down to the subprograms, please feel free to do that. I certainly understand that that's easier to understand. It helps you keep track of what variables are being used where. So please feel free to do that. Now it's important to understand that as you pass variables from the main program down to the subprograms, that those data types must match. And some very ugly things can happen if they don't. Um, it's possible to pass expressions, for instance, a specific string of characters as an argument, but the parameters must be variables. They must have a variable name. So when it lands in that subprogram, it's going to assign a portion of memory for that name that you've given it within those parentheses. And we'll see that in just a moment. You can assign data types to those parameters, but it's not necessary. So let's take a look at example 7.4 on page 360 real quick. Okay, so we'll see that we've declared a variable called message as a string, and then we instruct the user to enter a short message, and we have an input statement for that user to enter that message. And following that, we call the surround and display subprogram and send that the message variable. Now notice when that lands down here in the subprogram called surround and display, it has one parameter, and that parameter is called words. Now you'll notice that within these parentheses it is setting that variable as a data type string. So now my view on that is that since we've already declared that variable as a string up here in main, we don't have to do that again down here in the subprogram. So we can just do it that way. So now this variable message, pardon me, this variable message is coming down here to the subprogram surround and display, and that variable name is now called words. So the only line in that subprogram, it will write a series of asterisks and then the content of words, which was passed to the subprogram from main. So whatever the user entered here will now be displayed here, and then will be followed by a number of asterisks. Okay, it's possible to pass, as I mentioned before, it's possible to pass expressions as arguments to the parameters, but the parameters must be variables. So now it's possible to pass those expressions, like for instance a string of characters, to that variable, but it's really a bad idea, and there's a number of reasons for that. So real quick, now I don't have this example written out in Notepad++, but if you take a look at 7.3, this kind of demonstrates how sending the exact expressions with the call statement out to those subprograms work and how it can create some problems. So let's please not do that. If we're going to be sending values from the main program down to the subprograms, let's make sure that those values are contained in variables. So our variables are passed from the main program to our subprograms either by value or by reference. Passing by value sends a copy of the contents of the variable from the calling subprogram or the main program to the destination. And now it's important to understand that this is the default. If it's not specified otherwise, it's going to pass by value. And I'll show you how that works in just a moment. So the other type is passing by reference, and this simply creates a new label or a new variable name for the same memory location. So let's see how that works real quick. So this is example 7.5 on 362. Let me get there real quick. Okay, so we are declaring number 1 as an integer, and then we set number 1 equal to 1, and then again, watch watch what happens here. So we call the subprogram change value, and we send that the variable number 1. So at this point, the processing goes down here to the subprogram, and it identifies this variable called number as an integer, and it sets a number equal to 2. Now remember, it passed number 1 to this location, but since nothing was identified to behave differently, it's passing that by value, which means that the contents of number 1, which is 1, was passed down to this location, and a new memory location was allocated with a new label or a new variable name called number, and is given the value of 1. So, and then at this point, it goes into the only line of the subprogram, and it sets that value to 2. Now, again, remember, this is a different memory location, so when it returns up here to the main program, it will come down here to write number 1, and of course it's going to write 1 because that is the value for that variable within the main program. So now there's also passing by reference, and again, that pass by reference simply gives a new variable name or label for the same memory location. So let's see how that works. So we declare my number and your number both as integers, and we set my number to 156 and your number to 293, and then we call the switch subprogram and send that the variables my number and your number, which are both integers, and it goes down to this location, and both of these are set as integers, and again, it's not necessary to do that in the subprogram if you choose not to. And it has also changed the variable names. This is number 1, which matches my number, and this integer is number 2, which matches your number. So now watch what happens here. The integer number 2 is passed as reference. So what this is doing is giving a new label to this variable. I'm sorry, it gives a new label to the same memory address that this variable is pointing to. So watch what happens. So we set number 1 to 293, which is this first variable, which again was passed by value, which effectively sends a copy of the original variable down to the subprogram, new memory location, all that. And then it sets the value of number 2, which was passed by reference, which is a new label for the same memory location, and sets that to 156. And then it ends the subprogram, goes back to this location, and then it will write my number, which was 156, and notice that when it came down here and this was passed by value, this this value was changed to 293, has no effect whatsoever on this variable or the contents of that variable. So when we write by number, it will output 156, and then your number, which was passed as reference, actually changed the value in this variable. So when it prints that out, it will print another 156. Now, again, it's sometimes kind of difficult to wrap your brain around this, but it's very, very important that you understand how those variables work and um, how the labels or variable names are simply pointers to that memory location and the contents of that memory location. So let's take a look at this again. This is this is our memory addresses, and if we declare a username as a string, it immediately allocates a some memory location, and it gives that data type, a string data type. So we set the username to my name, and that goes into that memory address as a string value. So somewhere within the main program, we call a subprogram called my subprogram, and we send that the username variable, which we just declared and set up here. So once we land in that subprogram called my subprogram, and we have a new variable name or label called name. And notice what happens. So since this is passed by value, it allocates a new memory address and gives it a label called name, or the variable name. But now watch what happens here. If we change this to as reference, this now goes away, and this variable name called name now points to the same memory location as the username variable name that was declared up here in the main program. I hope that makes sense. If not, let me know, because it's very important that you understand how that works. Okay, and the text talks about a number of functions which are very, very very cool and certainly very useful in your coding. And I believe I mentioned before that functions are effectively subprograms that other folks have written that are available to you in what are called libraries. Now, in C++, you have to determine what libraries that you're going to need and include those in that at the very beginning of that code, and you'll see that later on when you take those higher level languages. So there are built-in functions which are part of that language, and then user-defined functions which are written by the user and now available in that programming language. So, and this is actually very, very cool because I use a lot of PowerShell at work, and I can write my own functions, and it's possible when you open that utility, which in PowerShell, the utility that I use is ISE, or the integrated scripting environment. You can set everything up so when that ISE opens, it automatically loads all those functions, so those functions are available to you. And you'll see how some of that stuff works. If you look at page 375, it has several functions on that at the top of that page. For square root, integer, ceiling, and we've seen a few of these already. Now, a couple of other functions that are mentioned a few pages back are functions called toUpper and toLower. Now, this these really help out with some of the defensive programming that we've discussed in the past, where if you ask the user to enter a character value of yes or no, you can set that to a or put that response through a two upper function, and then only test for a capital Y. So that way you don't have to test for is that variable equal to capital Y, or is that variable equal to lowercase y. You can just set it to two upper, and then just test for a capital letter. Pretty cool stuff. So that's about all I have. Let me go back through my notes one time and see if there's anything that I've missed. Oh, there's one detail that I don't think I covered. So when when the variables that are being sent to a subprogram from the main program, those variables have to be declared in main. Now, and they have to be declared by specific data type. Now, when they land in that subprogram and enclosed in the parentheses, they are already of that data type from the main program. So, as I've mentioned, you can indicate the data type for those within the subprogram. If that makes it easier for you to kind of follow what the data types are, that's fine. But you don't have to do that. Okay, so yep, that's all I've got for this chapter, the three sections in this chapter, and it's very important that we understand that from this point forward, there are certain things that are going to be changing about our code. Um, for instance, we're going to have the subprograms identified as subprograms beneath the main program. Um, and when a subprogram gets a variable value, that is going to be passed to that subprogram either by reference or by value. And now it's I don't think I went into the importance of the difference between those two. So if you pass that by value, it's going to just send a copy of it, which is not going to change the value in the in the main program. But now if you pass that by reference, you obviously need to make sure that you understand that if that subprogram makes any modifications to that variable, it's going to also make the modification to the variable in the main program. So be very careful with that. Um, Other than that, I don't think that I have anything else. There this is a lot of information, and we're effectively going to be changing the way that we write code this week for any future assignments and certainly the final project. So if you have any questions, please let me know. You have a number of ways to reach me within the Leo classroom. Please reach out to me if you have any questions, or if you're not clear on any of these concepts or any of the concepts from previous weeks. And good luck on the next assignment.